Hello friends, today we will learn about the theorem basic proportionality theorem. The statement of this theorem is that if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. If you draw the figure of the triangle, suppose ABC is a triangle, L is the line which intersects side AB in point P, which intersects side AC in point Q. Here, this line L is parallel to BC, means in triangle ABC, line L parallel side BC. Also, line L intersects side AB and side AC in points P and Q respectively. So, this line L, which is parallel to a side of a triangle, means line L is parallel to side BC, which intersects the side AB in point P, intersects AC in point Q. Then this line divides these two sides in same proportion. Means we have to prove here AP upon PB is equal to AQ upon QC. This is our to prove. Proof of this theorem is that we know that suppose these are the two parallel lines, line L and line M. In that parallel lines there are two triangles, triangle ABC and triangle ADC. Triangle ABC and triangle ADC. Both the triangles have same base AC, which is same. Both the triangles are situated in two parallel lines, means whose heights is also same. Height same. Means both the triangles have same base and same height, and so the area of both the triangles is also same because their height and base is same. Means the triangles whose height and base are same, they have equal areas. This property we have to understand first. So this property is also used in this theorem. So there are three steps for this proof of this theorem. First step is join BQ. By joining BQ, here we get two triangles, triangle APQ and triangle BPQ. If you observe triangle APQ and triangle BPQ, you notice that both the triangles are in the same triangle AQB. Means in triangle AQB there are two triangles, AQP and BPQ. So for these both the triangles, the height is same. because they are separate two triangles, but they are the part of a big triangle AQB. So the height of both the triangles is same, their base is different. Suppose this is a base 1, this is a base 2. Last time we had seen that the two triangles having equal height, then the ratio of area of such triangles is equal to the ratio of their corresponding bases. And so when we use this property, by applying this property, area of triangle APQ upon area of triangle BPQ is equal to AP upon PV. AP upon PV, called as, first give the reason, triangles having equal height. Triangles having equal height. This is the first step. Now, again, if we join PC, again here we get two triangles, APQ and CPQ. Now join PC. So in triangle APQ and triangle CPQ, here the height is also same. In both the triangles, height is also same. Base is different. Base first, base second. Again, by using the triangles having equal height, we also write the ratio of area of two triangles is equal to CPQ is equal to the ratio of their corresponding bases, AQ upon QC. That's called second. Give the reason, triangles having equal height. So these two statements are very important for proving this statement. Now we draw another figure here. Join BQ, join CP. Here. So here triangle BPC and triangle CQP. Triangle BPQ in triangle BPQ and triangle CPQ. Both the triangles have equal base PQ, and both the triangles are situated in two parallel lines, and so their height is also equal. Means these two triangles have equal base and equal height. In triangle BPQ and triangle CPQ have equal base and equal height. And when the two triangles have equal base and equal height, their areas are also equal. And so area of triangle BPQ is equal to area of triangle CPQ. We also write here they are situated in two parallel lines, and so their areas are equal. If we put these values in equation 1 and 2, if we observe that triangle APQ, triangle BPQ and triangle CPQ both have equal areas, and so we can write here area of triangle APQ, area of triangle APQ upon area of triangle BPQ is equal to area of triangle APQ upon area of triangle CPQ. Because both the triangles have equal base and equal height, and so the ratio of area of these two triangles is equal to ratio of area of these two triangles because of this statement, because both the triangles have equal height and equal base, and so their areas are also equal. So when you observe, suppose this is equation number 3. When we observe equation number 1, 2 and 3, we notice that the left hand side of equation 1 and 2 is equal. Obviously, the right hand side of equation 1 and equation 2 is equal, and so AP upon PB is equal to AQ upon QC. Here from equation first, second and third. From equation first, second and third. In this way, we can prove the theorem. So, some examples asked here that there are 4 things, 1, 2, 3 and 4. There are 4 things. Out of 4, 3 things are given. We have to ask the 4th thing. For example, suppose this is a triangle. This is a line which intersects this point P, this point Q. Here we have to given AP is equal to 10, PB is equal to 20, AQ is equal to 50, then find the value of QC. Find the value of QC. So simple, use the basic proportionality theorem here by BPT. AP upon PB is equal to 10 by 20 is equal to 1 half. AQ upon QC is equal to 15 by X. By using basic proportionality theorem by BPT, AP upon PB is equal to AQ upon QC. So put the values. 10 upon 20 is equal to 15 upon X. By cross multiplication, here 10x is equal to 20 by 15. So 20 by 15 divided by 10. If you calculate, the value of X is equal to 30. QC is equal to X is equal to 30. Means there are 4 things. Out of 4, 3 things are given. We have to ask 1 thing. Means here we can use BPT for solving the value of X. Now, in such type of examples,